Yes, so hopefully everything is good. Yes, so timer has started. Okay, so basically we had seen a 2009 question, and this is lecture number 8 of physics optional paper 2, lecture 8. Okay, lecture 8. Now, in this lecture 8, we will start from here. Okay, the questions, very similar questions to this, have been asked in the year 2012. Okay, in the year 2012, very similar question to this had been asked. Okay, and many in the many other years also such questions have been asked. Okay, so if you haven't watched the previous videos, then you can certainly click on the link in the description, or the link in the form of comments. You can click on that link and you can watch from the first class. Okay, if you are new to this channel. Okay, otherwise you can continue from here. Okay, but before moving on to the lecture number 8, I would like to announce some stars. Stars are as follows. Okay, the stars are Kusum Daksh and Nilam Daksh. Okay, these two are stars, and I am really very thankful to these people for giving me the love and respect. They gave me their love also, and they gave me their respect also. Okay, so thank you very much. Okay, you, may God bless you. Okay, so let's move on. Problems on finding the potential v of x when psi x comma t or psi x is given. Okay, we have to find the potential function, the potential function v of x when capital psi of xt. Capital psi of xt means what? Capital psi of xt means time dependent wave function. This is what? Time dependent wave function. Okay, this is time dependent. And what is this simple psi? This simple psi denotes time independent wave function. Okay, time independent. Okay, so potential v of x we have to find when these are given. Questions similar to these have been asked in the 2012 year and many more years. Okay, so working rule is very simple. We have to solve by using this formula. Okay, Hamiltonian of psi x comma t equal to I h cut del by del t psi x comma t. If time dependent function is given to us, if time dependent wave function is given to us, then we have to use this formula. Okay, and if time independent wave function is given to us, then we have to use the formula given in the below side, downside. Then we have to use this formula. Okay, for the time independent one. So the second formula which you see in the downward side, that is basically your time independent formula, and this is time dependent formula. Now what's the difference between the two? Okay, what's the difference between the two? Okay, so over here it is written that h psi x comma t. Okay, so let me write over here h psi x comma t is equal to what? I h cut del by del t psi x comma t, right? I h cut del by del t psi x comma t, right? And in the other case it is h psi equal to e psi. Okay, in the other case when time independent function is given, then this is the formula you have to use. Now while using this formula, some people ask that in the downside in the formula which is given below, and the downward formula has e in it. It has e in it, and the upward formula does not have e in it. It doesn't have e in it. Instead it has something else. Instead it has this thing. Okay, I h cut del by del t it has, right? So obviously I h cut del by del t is there, and this is basically your e. So what is the difference between the two? The difference is that over here the function psi is a function of x and t. Over here the function psi is a function of x and t. So if I take del by del t of some function which is a function of x and t both, then it will not yield 0. It will yield something. It will yield something. But over here, if I simply use this formula over here, if I try to use the same formula, I h cut del by del t over here in the second formula, instead of e psi, if I write this thing, then definitely this thing will always be 0. Okay, this thing will always be 0 because psi of x does not contain t. So as psi of x does not contain t, so it is quite obvious that it is a function of x only, right? So suppose it is x square. So when I take the partial differentiation with respect to time of this function which is independent of t, then obviously I will get 0 because it is equivalent to taking derivative of a constant. It is equivalent to taking derivative of a constant. Okay. So that's why in the first equation I have used I h cut del by del t, and in the second equation as it is independent of t, that's why I have used e instead of I h cut del by del t. Okay. So this is the thing which you will have to remember. Okay. So I have written over here also that do not write I h cut del by del t here. Okay. Do not write I h cut del by del t over here in the second formula because partial differentiation will always yield 0. Okay. Because this e will always yield 0, right? This e will always yield 0 over here if I take this value of e. Okay. So now we will move on to example number 1. The eigenfunction for the Hamiltonian of a particle. Okay. The eigenfunction for the Hamiltonian of a particle of mass m in a one-dimensional potential v of x is given as. So eigenfunction for the Hamiltonian of a particle is given like this. This is basically the eigenfunction of Hamiltonian of a particle of mass m in one-dimensional potential v of x. Okay. So it is given like this, where a and b are constants. So we have to find the potential energy function v of x. Okay. We have to find v of x. So you can clearly see this, that this is basically what, time independent one. Okay. It is basically time independent. So as it is time independent function, as it does not contain t term, it does not contain t term, right? And also over here also it is written in the form of this psi x instead of psi capital psi x comma t. Instead of capital psi x comma t, it is written psi small x. Okay. Small psi x. Okay. Small psi x has been written. So small psi x basically implies that it is going to be a function of x only. There is no t term in it. So which formula will be used? Out of these two, which formula is going to be used? You only tell me. Whether this formula will be used in this question, whether this formula will be used or whether this formula will be used. Okay, in this question. So it is very clear that the second formula will be used in this question, because in this question this is not given. This is not given. Instead this is given. Okay. So second formula will be used in this question. Okay. Second formula will be used in this question, this formula. Okay. So because there is no t term in it, if I try to use this formula, then the right hand side will always yield 0 to me. The right hand side will always yield 0 to me, because del by del t of a function of x only will only yield me 0. Okay. So in order to avoid that, I am not using this formula. Instead I am using h psi equal to e psi formula. Okay. So let me use that formula over here. So h psi equal to e psi. Okay. So I used that. Now h psi equal to e psi. Then what we need to do is to substitute the value of Hamiltonian. What is a Hamiltonian operator defined as? Hamiltonian operator, your Hamiltonian operator, it is defined like this. Okay, over here it is Hamiltonian operator, right? So this h operator, which is called as Hamiltonian operator. Okay, and these operators will be more clear to you in the upcoming classes. Okay, upcoming classes is equal to operators will be explained in detail. Okay. So let us use this formula. So for in the case of Hamiltonian operator, I will substitute this term. Okay. Instead of Hamiltonian operator, I will substitute this term over here. Okay. Hamiltonian operator is defined like this. Okay. So your psi, h psi turns to what? H psi turns to, you basically substitute h over here, and you substitute psi of x, which has this value, over here. So ultimately you get this thing which has been written over here. Okay, you ultimately get this thing which has been written over here. Okay, this thing. So you get this thing because, why you get this thing? Because you substitute in the place of h this term, and you substitute in the place of psi this term. So you ultimately get this. Okay. So equal to EA. Now in the right hand side also, I will substitute this for psi of x. Okay. I will substitute this. So ultimately, this goes inside the operator. This goes inside the operator. So as it goes inside the operator, it is very clearly visible that it will be taken double derivative. Okay, double derivative will be taken. Okay, and over here it will be multiplied by potential energy function. So potential energy function, it is getting multiplied equal to EA, not potential energy function, potential function. Okay, so EA e to the power minus b x square by 2 on the right hand side. Simply I have taken this inside the bracket. Okay. So after taking it inside the bracket, while solving this, now this part I have to solve. Double differentiation I have to find, right? So I will first of all differentiate it one time. Okay. I will first of all differentiate it one time. So when I differentiate it one time, it is basically d by dx of d by dx of a e to the power minus b x square by 2. Okay, it is like this. So I will take double derivative. Now single derivative when I take single derivative of this thing, so it is quite evident. Let me write over here that a will come out of the differentiation symbol, and it will be d by dx of e to the power minus b x square by 2. Okay, now after I take the differentiation, this term will remain like this. Okay, and again d by dx of minus b x square over 2. Okay, so a e to the power minus b x square by 2, then this minus b by 2 will come out and this will be 2x. Okay, then 2 and 2 will cancel out. Okay, then I will get minus a. Okay, what will I get? I will get minus a. Okay, uh, minus a b x e to the power minus b x square by 2 I will get, right? Then again I will basically differentiate this again with respect to x. Okay, because it is double differentiation, right? So this term, the result obtained, will be differentiated again with respect to x, and when it will be differentiated again with respect to x, I will basically use the UV formula. Okay, so I won't go into the differentiation of that. It is a very easy differentiation. I think it is the one of the easiest differentiation on earth. Okay, so single time differentiation, after it is done, we obtain this. Okay, after single time differentiation we obtain this clearly. Okay, so from here we have to find the differentiation once again. So these 2 and 2 will cancel out. Okay, then minus a b will come out of the bracket, right? I mean differential. So it will be d by dx of minus ab. Okay, so minus ab e to minus abx e to the power minus bx square by 2. Okay, so ab will come out, minus ab will come out. Okay, then d by dx of x e to the power minus bx square by 2. Okay, then again we have to do the differentiation 2 times, right? 2 times means UV formula. Okay, so one time this function. Okay, keeping the other constant. Okay, so one time x has been differentiated, keeping this as the same. Then again x will be taken as it is, and this will be differentiated. So while differentiating this, we will get minus xb in the multiplication. Okay, right? So then this will become eventually the thing which has been written over here. Okay, the thing which has been written over here, it will become like that. Okay, then so I have explained each and every step over here, and after that you go on solving it mechanically. So you will obtain this thing, and you will realize that a b e to the power minus b x square by 2, a e to the power minus b x square by 2, a e to the power minus b x square by 2, all these things will be cancelled out. Okay, so you are left with what? You are basically left with, just a second. Okay, you are basically left with this thing in the last. You will separate out vx. After solving the algebraic expression, you will basically separate out vx to one side and all other terms to the other side. So basically you will get the potential energy function like this. Okay, potential energy function or potential function. Okay, so you get it like this. Okay, so this is the thing which in this way this problem has had to be solved. Okay, now this problem has already been included in your notes. If you see the notes which have been posted on Telegram, the Telegram notes already have all these things in it. Okay, Telegram notes already have all these things in it. Okay, so you can download the Telegram notes and take the benefit from there, because I can't provide these also to you. Okay, because if I provide these also to you, it will be the Telegram will be too much overloaded with the content. Okay, so instead of providing it, instead of doing duplication of efforts, I have one time posted the PDF, so you can take the benefit of the PDF from there. You can search this part. Okay, it will be written like this only. Okay, in the PDF also it is written like this only, in this language only. So eventually you can find the page on which this has been given. Okay, so if you find the page, you will find there this there. Okay, or else you can make the notes also, no problem. You can pause the video and make the notes also, not an issue. Okay, now this how has this come? Okay, E minus B h cut square by 2m. So from here again one step has been done over here, that x term has been separated out and constant terms have been separated out. Okay, so you can clearly see this thing, that when I multiply this by this, I will get the x term. Okay, I will get the x term, right? And if I multiply this by this, I won't get the x term, I will get constants, because b is a constant. Okay, so basically I will just separate. Okay, this multiplication with this I will separate, and this multiplied by this I will separate. Okay, so basically I will write the constant along with this e. Okay, I will write the constant along with this e, right? So this is the final potential energy expression which you get. Now one thing is very remarkable over here, that it is given that one dimensional potential is given. Okay, okay, so it is not given that energy is constant. Okay, it is not given to us. So you got the potential function like this. This is the answer. Okay, now in the university exam, what is the difference between the university exam and IS exam? I am telling you that in the university exam, when such a result is obtained na, when such a result is obtained in the university exam, when such a result is obtained in the university exam, you can stop the answer here. In the university exam you can stop the answer over here, but in IAS exam, IAS physics optional exam, whenever such a result is obtained, okay, whenever such a result is obtained in exam, IAS exam, just check whether I can draw its graph or not. Okay, because you have to grab here marks. Okay, so just check whether I can draw its graph or not, and also describe the graph or not. Okay, just check whether I can draw its graph, or whether I can describe the graph a little bit, or whether I can describe the equation a little bit. Just have a look at that. Okay, so in university exams, solving up to here is more than sufficient, but in IAS exam this is not sufficient. You have to draw graph and describe it a little bit in your own words. Okay, you have to draw a graph and describe it a little bit in your own words, so that you are able to grab more marks. Okay, you have to do this in the IAS exam. Okay, so now the expression in the box can be compared with the general equation. Now up to here it was a notification. Okay, up to here I I guided you up to here. Okay, up to here. So again the solution starts from here once again. So now the expression in the box, this expression in the box, okay, can be compared with the general equation of a parabola. It can be compared to the general equation of a parabola, which is f of x equal to m dash x square plus c, which is the general equation of a parabola. Okay, now here f of x is equal to v of x, m dash is equal to, basically you are comparing this term to m dash. Okay, and this term to c, this term to c, and this term to f of x. Okay, so y equal to f of x equal to m dash x square plus c. This is the equation of parabola you might have learnt in your lower classes. Okay, so from here I can write like this. Okay, and after that c, value of c has come out to be this much. So graph can be plotted as follows. Now you can clearly see, you have to understand that you need to remember the nature. Okay, you have to remember the nature of the function. So in the IS exam, you can't stop the answer here. Okay, you cannot stop the answer over here in the IS exam. Okay, you have to this is a notification, you have to write this also in your IS exam. Okay, the thing which has been written in the downside. Okay, so you have to basically remember the nature of certain functions, okay, which is like if the power is 2 means a square function, okay, so the equation is a square, square means quadratic equation is there. So in quadratic relation, parabola is the curve which we obtain. In cubic equation we might obtain certain other curve. In the linear equation we might obtain a straight line, right? So you have to remember such generalized results, okay. So you have to use that JE time concept over here, that whenever the equation is of the form, whenever the equation is of the form this, okay, you can clearly say that it is a parabola, okay. This thing you have to remember, and this is basically a symmetric parabola, okay. Symmetric parabola, symmetric about y-axis, okay. So according to that theorem from the JE time, I can draw the graph as follows. So basically now how to find this y-intercept, okay, how to find this y-intercept, how did I find this y-intercept? Now you know this very well, that at this y-intercept the value of x is 0, the value of x is 0, okay. So value of x, if I put 0 over here, if I put value of x equal to 0 over here, then clearly I obtain v of 0 equal to this much, okay. So as I obtain v of 0 equal to that much, so clearly I obtain the y-intercept of this parabola, okay. So this is the y-intercept of this parabola, and it is equal to c means this much, okay. Now this is the parallel tangential line, this is the parallel tangential line, okay. And the parabola will lie above this. Why it will lie above this? Because it is of the form, it is of this form, right? So as it is of this form, so clearly it will never give negative value, it will never give negative value. So as it will never give negative value, so it is quite obvious that if I try to draw the graph like this, then it will go in the negative region also, okay. It will go in the negative y also, but y's value can never be negative because x square is always positive. So basically I will have to keep the mouth of the parabola upwards instead of downwards, okay. So mouth of the parabola opens upwards, okay. So basically I have drawn this graph, and this and how did I come to know that this nature, this type of equation yields parabolic graph? How did I know? I knew this from the JE time concept, JE time maths concept. I know this, okay, that a parabolic equation looks like this, and its curve is like this. I have learned it in the JE time, so I am using that concept, okay. So it is a parabola symmetrical about vx axis, okay. Why is it symmetrical? You can see now. Why is it symmetrical? You can see this clearly, that if you put the value of x, put the value of x equal to 2 suppose, and if you put the value of x equal to minus 2 suppose, both are going to yield you the same value, okay. So if I draw the graph over here, this is my y-intercept. So if I go x equal to 2 over here, if I go x equal to minus 2 over here, then clearly I am going to get the same distance on both the side from here, okay, same distance from here. So basically my graph will look like this, it will be symmetrical, okay. Similarly for x equal to 1 and x equal to minus 1, it is going to have the same value, right? So for every pair of positive and negative values, it is going to have the same y value. Y value means v of x value, or over here we have plotted v of x instead of y, right? So it is basically parabolic equation, symmetrical parabola, okay. So this is a very common sense type of thing, okay. So it is a parabola symmetrical about vx axis. The value of v of x is minimum at x equal to 0, which is v of 0 equal to c equal to this much equal to y-intercept, okay. The value increases above this minimum value in positive x direction, okay. Value increases above this minimum value, above this minimum value, this is the minimum value. The value increases above this minimum value in the positive x direction, and value increases above this minimum value, value increases above this minimum value in the negative x direction also, okay. So it is resulting in a symmetrical parabola basically, okay, right? Now we will do the second example in the next class. Till then, Jai Hind, Jai Bharat, okay. अपना ख्याल रखें.